Grade 11s, we're looking at Analytical Mechanical 6, and we're going to zoom in on the instructions so that we can look at the different components and answer those questions. Parts of a pulley tensioner with a title block is given to you and a table of questions. These are the questions, those are the components. You will find the list, the part list of the components. There's 1 right down to 5 from the base to the washer, and it continues this side from the spring right down to the M10 nut. So it is a part, a quantity and material. Part, quantity and material. Question number 1. What is the indicated scale on the drawing? So you're going to scroll down here and you're going to find the scale as 1:2, and that's what you're going to write in there. 1:2. From what material is the spring manufactured? So we're going to go to the part list and you're going to find where's the spring, and you're going to find it right there. It's made of spring steel. So we're going to write in there spring steel as your answer. Which drawing program was used to create the drawings? And we're going to scroll down right in this corner here where you find that the drawing program was AutoCAD 2015. So that would be AutoCAD 2015. What is the name of the drawing file? So we're going to go down here and we're going to look for the drawing file name. That is going to be TEN-53-2017. So let's write that in there. 10 TEN-53-2017. Question number 5. What is the website address of this company? So we're going to go down to the title bar again. There's the company. It's in Middelburg. It is www.pulley.co.za. www.pulley.co.za. Okay. What is the tolerance allowed on the dimensions? So you're going to scroll down to the shaded area again and you're going to read the unless otherwise specified, tolerances on dimensions are plus minus, and you must get in the plus minus 0,35. So we go to our answer block, plus minus 0,35. Why was the drawing revised? So we're going to go to the revision section here. There's the revision, that is the change. And we're going to find that there had to be a spring specification. That was the change, the spring specification. We're going to write the spring, and that's going to be your spec, the specifications that you will have there. Okay. Number 8, at what angle is feature A drawn? So we're going to look where feature A is. It's that little slant over there, and that easily could be identified as a 45-degree angle. So there's my 45 degrees. What is the feature B called? So we're going to go to B. B has the double line here, and it has a double line on the top, so that could only be screw thread. So I'm going to write in here screw thread. Sorry. Okay. Screw thread. Apologies for my handwriting. Let me just rewrite that, and that's going to be T-H-R-E-A-D. Screw thread. Okay. Number 10. What is feature C called? So we're going to have to look at feature C. That is there. That's an S brake according to our analytical information. So S brake. And should you be asked what the function of an S brake is, it continues. Okay, I mean the shaft continues. What is the feature D called? So we will have to go up and find D on the page. It refers to that little nook there, that little quarter circle. That is a fillet. That is a fillet. Okay. Please take note. All those little nooks inside a component is called a fillet. The next question, number 12. What is the radius of the arc at D? So what is that specific radius that we spoke about now? So they don't give it to you, and there are quite a few of them. You have to scroll down to your title bar and find it right there that all unspecified radii all over are 6. R6, radius 6. So you can just write in the R6. Right. Identify the type or the line type, the type of line at point E. So we have to go to point E, and point E you're going to find there, and that is a hidden detail. It's not a dash, it is a dash the way it is, but it's called hidden detail. So you're going to write in the hidden detail. Okay, let's go to the next question, number 14. What does the double arrow at F indicate? So there is going to be the double arrow at F. That means with the S brake there, that is the full length, the total length. So we're going to write in here the total length of the component. Okay. Next question, number 15. Determine the dimension at G. So let's go to G. G could be found right on top here. There's G. So you need to do a few calculations here, and I'm going to do it right here. We have that there, which is the 30, and it's from that center to that center, but we need it from here to there. So we find that that is the radius, that side from there to there, which is 23. So a plus 23 this side, and we go over to this side and we find there's an R18 from that point to there, plus 18 that side, and all together they will give you 71. Right, so you're going to go down to the answer block and write the 71 is the dimension. If a standard size M10 nut was used, calculate the thickness of the nut at H. So we're going to go down to the nut. So this is an M10 nut, and there's a standard format that you use to determine that there, the height. And this is what it's all about. You're going to say M10, it's basically just refer to the 10 times 0,8. 0,8 will be for the height calculation of a nut, and 0,7 is the height calculation of a bolt. And that calculation is going to give you an answer of 8. That's why it's 2 marks. Very important, that 0,8. It's a standard size. Even if it was M20 and M15, it always is multiplied by 0,8 for a nut. What type of section is shown at the bearing? And we go down and we find the bearing on top here. There's the bearing. There's a section. It's only on the top part, which is only on the top half. So it's a half section as an answer. Half section. We look at question number 18. What does AF mean at the M10 nut? So we're going to go and scroll up. It is found right there, AF15. That AF means across flat. It's basically, if you look at it from the distance from that flat part there to this flat part over here is 15 millimeters. Question number 19. In the box below, a neat freehand of the Sands convention of the bearing. So that is the bearing here as a picture. So you need to draw a Sands. So you can either draw it vertically or horizontally. In this case, there's more space horizontally. So I'm going to draw a rectangular shape like that. And then one side will be the one part of the bearing and the other side will be the other part of the bearing, and this will be an actual hole here, and then you will have a cross here and a cross or diagonal both ends. Don't forget to put in your center line, long short there, and that basically shows you the symbol of a bearing, right? Don't forget the center line, as I've mentioned, very important. Okay, number 20 and the last question in the box below. Freehand the symbol of the projection system that was used in this case. There you get the line. Remember what I said, across there of the short one, long one here, long one there. Small circle, big circle. Small line for the small circle, longer line for the bigger circle. Connection there. Connection there, and voila, there you have your symbol.